All right, we're going to work on lesson 7.1 again today. But today we're going to actually get into being able to graph and find solutions to systems of equations. As yesterday we started working on how the makeup of a system and then what the solutions could look like. Today we're going to actually get into it. All right. So to solve a system of equations by graphing, uh, we got like a simple three-step process that we'll go through. Step number one, you're going to be given a system. The first step is to make sure each equation is written in slope intercept form so that we can make a good graph. So if it's not solved for y, we'll solve it for y so that we have it as y equals mx plus b. Pick out the slope, pick out the y-intercept, make our graph. Step two is going to be to take the information and graph the two equations on the same coordinate plane. Now, everything we do tonight will be through our ALEKS site, which is going to provide the graph and the tools to do that. So we all be able to make good, accurate graphs. And then step three is use that graph to determine the solution. We know there's a group of possible solutions out there, right? There could be one solution, and that's when the two lines intersect and you find that point of intersection. There could be no solution. That means the lines are parallel. Now, since we're setting these up to graph them, we'll know this ahead of time. If the two lines have the same slope and different y-intercepts, they're parallel. It will be no solution. Okay. There could be an infinite number of solutions. And again, we'll know ahead of time if this happens. Okay. That shouldn't say if the lines are parallel. Okay. If we have an infinite solutions, then it's the same line over again. And you'll know that. You'll see the same slope. You'll see the same y-intercept. That means it's the same line. So that means we got an infinite number of solutions. Okay, so that's our process for solving these systems of equations, and we're going to work through some of them now. All right, so here's a system of equations. We're going to graph them. We're going to then write its solution, and it could be a no solution or infinitely many. And down here, you can see your choices. All right, you're going to use this graphing utility to get our solution. This is the work in my mind that we would show. Okay, so our first step in the process is to write our equation so they're solved for y. This one's already solved for y. So I know the slope is 2, which I wrote as 2 over 1 because we like a rise and a run. I didn't have to do that. I don't want to confuse you, but we have a rise and a run. So I'm going to go with the slope of 2, y-intercept of 3. Okay, so then I come over here. I mark 3 on my y-axis. I go up 2 over 1, up 2 over 1, draw a line through it. This line is now graphed. Second line, y equals x minus 2. Okay, got a slope of 1, which I wrote as 1 over 1, rise of 1, run of 1. And I got a y-intercept at negative 2. Take that information, come over to the same graph. We're going to cross, oopsie, down here at negative 2. Looks like, no, yep, looks like I boogered this one up. Cross here at negative 2, right? Oh, you know what? It should have been a 1. I screwed this part up. All right, this should be a 1, and this should be a 1. So this is right down here. Rise of 1, run of 1, rise of 1, run of run, draw my line. I can clearly see that these two are going to intersect, and they're going to intersect at the point negative 4, negative 5. All right. Don't you make those mistakes. I did. All right. Let's do another one. Another one here. So here's my two equations. That's my system. Don't have a lot of work to do to graph it. I'm just going to rewrite it here. So y equals negative 3x plus 3. My slope is negative 3. I wrote it with a rise and a run. My y-intercept is at 3. So I'm going to come over here, go to the y-axis to 3. Okay. Rise of 3, run of 1. Remember, negative slope. So if I go up, I go to the left. If I go down, I go to the right. Draw the line. Okay. My other line, opposite of x minus 1 is really a negative 1 right there, right? So my slope is negative 1, which I wrote again as a rise and a run, didn't have to. Y-intercept is negative 1. So come over here to negative 1, up 1 to left 1, up 1 to left 1, make our markings, draw our line. And again, we can clearly see we have an intersection, and our intersection occurs at 2, negative 3. All right. Now, this one now is a little bit more challenging, right? Because your first equation is ready to go, but your second, you got to put in slope-intercept form. That's not tough for us, right? Here's my first equation. It's ready to graph, right? My slope is a half. My y-intercept is negative 1. We'll come over here to -1, go rise of 1, run of 2, rise of 1, run of 2. There's my line. Now my second equation, right, I got to solve it for y because I want to make it y equals mx plus b. I'm going to add 2x to both sides to get y equals 2x plus 2. Okay, remember we're going to make this a 0, so we're going to add 2. So now I know my slope is 2, rise of 2, run of 1, and I know my y-intercept is 2. So I'm going to go here to 2, make a mark, up 2 over 1, up 2 over 1, or down to the left 1. My two lines intersect, and you can clearly see their point of intersection is -2, -2. Okay, no problem. One more. So this one, my top equation now is the one I got to do a little extra work on. My bottom one's ready to go, but we got to get them both ready to graph. So here's my top one, 2x plus 6, or 2x plus y equals -6. I'm going to isolate y, so we're going to subtract 2x. Y equals -2x minus 6, slope-intercept form. Slope is -2, y-intercept is -6. So I'll come over here to -6, put a point. I'm going to go up to the left one, to get my negative slope. There's my line. Second equation, y equals 1/4 x plus 3. That's already in slope-intercept. Slope is 1/4, y-intercept is 3. Come up here to 3, put a point. Up 1 over 4, down 1 to the left 4, draw my line. There's my point of intersection, and the point is at -4, 2. Okay, so pretty straightforward here how to do this. I didn't run any no solutions or infinitely many, but that can happen. Okay, you guys be able to handle it when you see it. All right. Now the last concept for today is to flip this thing around. Let's give you a graph, and you write the system that's represented by the graph. All right, so essentially what you have to do is write an equation for each of the lines and then put them together in the system, and I'll show you how to check to see if you know you're right. So what I'm going to do is just call this one equation 1. All right, to write the correct equation for number 1 here, I need to know the slope, I need to know the y-intercept. Well, the slope is I went from this point to this point. They're labeled. It's a rise of 8 and a run of 2. So I went up, which is technically positive, to the left, which is negative. So I got 8 over -2. That's -4. So the slope of equation 1 is -4. And then the y-intercept is at 5. So those are the two things I need, slope and y-intercept. So here's my equation. Y equals -4x plus 5. There's my first equation in my system. This is our second equation. So again, I need to know two things: slope, y-intercept. Slope, pretty easy. Rise of 1, run of 2. Y-intercept, pretty easy. It's right here at -4. Equation, y equals mx plus b. Okay, and then plug it in here. Now I said you could check it, and here's what I was thinking. We know the answer to the intersection, which is the solution to the system, is at 2, -3. If you put 2 in place of x and -3 in place of y, it makes it true. -8 plus 5 is -3. 2 in place of x, -3 in place of y. 1/2 times 2 is 1. 1 minus 4, -3. So you can check to make sure your system is correct, but that's what they want. Okay, one more of these. Okay, same process here. I'm going to make this first line equation 1. Doesn't matter which one's which, guys, as long as you have the two equations here. So for equation 1, I need the slope, I need the y-intercept. So point to point, up 1 to the left 2, up 1 to the left 2. So my slope is -1/2. My y-intercept is right here at 5. Y equals -1/2 x plus 5. There it is. All right. The next one, equation 2, I got a rise of 1, 2, 3, 4, 5, 6, and a run of 2. That's +6 over 2, right? So that's a slope of, oopsie, I guess I got it out of order. The slope is 3. Y-intercept's at -2. So y equals 3x minus 2 is my second equation, right? And to check if I'm right, 2, 4 is the answer. So it should make both these true. So if I put 2 in place of x, -1/2 times 2 is -1 plus 5 is 4. Put 2 here, 2 times 3 is 6 minus 2, 4. So that's the answer that goes with this system. So we are correct. All right. So that's what your homework's going to look like tonight. It's going to be on Alex. Write the work down that it takes to show the process and how to solve these. And, I'll let you have at it.